I also take this opportunity to welcome everyone to this webinar. It is the first of many webinars that we are going to be having in response to stakeholders' calls for enhanced communication and information sharing in the fisheries sector to support evidence-based decision-making. For those who may not know the National Fisheries Resources Research Institute, NaFIRRI, very well, we are a public research institute in Uganda with a national mandate to conduct research on all aspects of fisheries and aquaculture. Our headquarters are in Jinja, on the shores of Victoria, which is the subject of today's talk. But we also have a station that works on aquaculture research and development in Kampala along Entebbe Road. In the past few weeks, about 3 weeks, the media, actually both local, regional, and international, have covered a very important topic, Lake Victoria turning green. That media coverage followed a publication from a diverse team of scientists in the East African region and beyond that reported tens of harmful cyanobacteria that are actually responsible for the greening of the lake. Now, given the importance of Lake Victoria, which I know everyone is conversant with, this is an important topic because it has implications, many implications in the social lives of people who live around the lake, the economies of the countries, and so on. We thought that we should have a conversation to become, to obtain more enlightenment on this situation, but specifically get opinions on what all this means for fisheries and aquaculture. So for today, our speaker is Dr. Mark Orokotum, who is a senior research officer at NaFIRRI, but also heads a research program in the same institute that is actually concerned with the environmental aspects of fisheries. So I'd also like to note that he was actually part of this team that he published this recent paper that caused this comprehensive coverage of the greening of the lake in the media. So without taking more time, I'd like to invite Mark to share his screen and start the presentation. But as he does so, I would also like to note that he's actually been working on the subject since 2017. So we are privileged to hear from a scientist who has a lot of knowledge on this subject that has been accumulated from very many years of research. After his presentation, we shall have time for discussion. We're interested in your experiences, including what you think can be done to get remedies of this situation that is not present if it takes the whole lake. Mark, when you're ready, please begin your presentation.
I'm honored to be one of the persons to participate in the knowledge sharing of our prestigious organization. And particularly today, we are going to talk about greening Lake Victoria and also what it means for fisheries and aquaculture. And I want us to start by an experience. So I will start with a simple question on what is your experience with the greening of water bodies. And particularly in this case, I want us to just focus on Lake Victoria. If you take a small boat cruise, I'm here going to share with you a small video. I hope it runs. So we can see how the water is changing in color. So at this point is when we decide to take a sample. Of course, it's always a big team, and we try as much as possible to cover a big area on the lake as much as possible. So let's go straight into the history and timing of the greening of the lake. With that video in mind, that video was taken in 2020 and then in 2022. And then a few pictures were taken in 2023. And from what Dr. Msinguzi has said, there's a paper that we published that came up with now the molecular characterization of what is actually causing the greening. But for purposes of this, we need to have a history. Where are we coming from? Well, in the 1950s, we had the introduction of Nile perch, and in the early 70s or the mid of 1980s, there was a massive explosion of Nile perch. Now, this is very interesting because during the same time, it's when we observed, or the early researchers observed the starting of the greening. And this is directly due to the loss of the haplochromines, according to several published papers and researchers in the early days. These used to be a very complex food web. But once the Nile perch was introduced, the food web was simplified. And definitely there was other organisms that were going to dominate. Now, when we move fast forward in the mid-90s, especially in our bays and gulfs, we see that there was industrial development. If you look at Kampala, Jinja, Entebbe, Mwanza, Kisumu, all these are on the shores of the lake. And of course, there are things we cannot take out of the picture, which environmental variables, which climate change and variability. Now, that was happening, but there, of course, there were interventions that were happening within those timeframes. So over the years, we saw that there was a Lake Victoria Fisheries project that came in the process in the early 1990s, early 2000. Mid 2000, we had LAVEMP, the famous LAVEMP. Most of you know about LAVEMP, which is Lake Victoria Environmental Management Project, which were in two phases, the first phase and then the second phase. But the most interesting thing with all these interventions, they are coming in place because of the nutrient loading or eutrophication or the greening of Lake Victoria. Now, with these interventions, there was no interest in cyanobacteria or the organisms that are actually responsible that we see in the greening of the lake. Now, in the early 2000s is when this comes on board. And these studies were focusing mainly on what cyanobacteria is there and what toxins are being produced. Now, as we move, I want us to appreciate that all of us are responsible for what we are seeing in Lake Victoria. And I will say this authoritatively because our population is growing. As Uganda now, maybe we could be 49 million Ugandans, and we all demand food. We need to be housed and we need products. So we need industries to be there. We need to put up nice buildings, and then we need food. Of course, we have to turn the shores, the wetlands, and so many other areas to support agriculture. That consequently gives us erosion, dust emissions, and these contribute the nitrogen and phosphorus. And where does it end? Into the lake. When you're doing your housing, you find where you compact soils, and when you're compacting them in the wetlands, you are decreasing the natural processes. Still, when there is runoff, it ends into the lake. The industries, there is liquid and solid wastes. So basically, we are responsible for the greening of the lake. So that means it is a common responsibility for us to also come and find a solution to what is happening in the lake. Just to give a simple analogy on what happens. So if we set up a factory or a settlement or nice apartments, there will be discharge, there will be runoff, there will be pavements and so on. All these will end in the lake. And then when you're in the lake, there's greening. But of course, there are some of us who enjoy going to the beach. We go swimming. We are exposed. There are fishermen who like to get fish. There is the national water supply that they also have to they have to produce water for you, especially those of us who are living in towns. So the cause and consequences are moving hand in hand. So therefore, once we have this greening, the photos actually you're seeing are taken almost not in the middle of the lake, but several kilometers in the lake. So these greenings are responsible for cyanotoxins. So these cyanotoxins are quite diverse. We have cylindrospermopsins, anatoxins, saxitoxins, or microcystids. Just basically, let's understand them as toxins. Now, we are responsible for the greening, but also we're exposed. either through consumption of water or regression, or when we eat the fish. Because the fish lives in water. And we need the fish, we need to survive. And of course, when these toxins are produced, they are highly soluble. They are soluble in water. It is possible to accumulate in fish. They are highly soluble. It is possible not to be removed during water treatment. Now, just to look at the three major towns that are highly developed, that are hotspots. Let's look at Kampala, Kisumu, and Mwanza. When we look at these towns, they have one thing in common. Since the year 2000, the lake area has totally changed green. And anytime we get a person going there to take a sample or something, he will report what you see in the newspapers, what is published, and totally green. Then this greening is dominated by mainly two species. And these species are Microcystis and Dolichospermum. Dolichospermum is formerly was called Anabena. Now, these two dominant species are responsible for at least 30 variants. 5 to 30 variants have been reported at different times. So if those of us who were during the COVID, we remember when the president was closing the country because of variants. So these toxins also have variants. There are those that are highly soluble, there are those that are highly toxic, and so on. But when we go in the middle of the lake, for example, we go further, yes, the concentration is low, but still there is cyanobacteria, or the greening is there. And we have less variants of the toxins. So that means we have different levels of exposure, different levels of greening. Responsible and the responsible organisms or cyanobacteria are nearly the same, but just what varies is the magnitude. Now, if we look at the fish communities, definitely fish communities would not be willing to live where it is highly green. One, because when there is a decomposition, of course, the green algae or the cyanobacteria dies, and then it sinks to the bottom, it decomposes, and then causes anoxia. There should be specialized fish species that actually want to live around that area. So at any one point in time, the composition of the community will be changed. Then from previous research by Kumbo and Marshall, they tried to disentangle the causes and changes in the stocks of Nile perch, but they can only confirm that between 2005 and 2011, the fish community, the changes in stocks of Nile perch could be associated to the increase in the greening of the lake. But let's not forget that Nile perch was already responsible for disturbance of the trophic network within the lake. Now, also when we look at where these organisms or the greening or the cyanobacteria is, there is more of a change in the trophic network. Therefore, at the initial areas, those who joined early, if you saw that video, at the initial area, you can even see bubbles of air coming out and so on. So the fishes communities around there would be few. And then you would find that there's only bacteria and cyanobacteria in that place. Now, I don't want to dwell so much on the fishing communities and so on, but we need to know that when the water is contaminated, we are directly exposed. And we as fishers and fisherwomen, we live along the shores. We'd love to have our lives along the river, along the lakes, and so on. If you see in that picture, people are swimming. You have gone to the beach, you're exposed, you have asked for fish at the beach, you are consuming fish, but we don't know how much concentration you're actually taking in. Now, we, like Laban, Dr. Msing was mentioned, we wanted to know how would the fish respond to the greening. So we set up mesocosm experimentations. And in these experiments, we tried to extrapolate how much increment we can do, how much green can the fish withstand, and how, if they can withstand it for how long. Then, if we get the fish, has it consumed the cyanobacteria or the green? And then if it has consumed, does it biomagnify? Does it increase in concentration within the fish, or is it transferred to other organs and that are of interest to humans? So we are trying to make a cascade test. Now, what you see here are just plastic bags, and we use in situ conditions, getting the water and putting it in those bags, and then introducing in fish, and then monitoring them over a period. Now, just a simplified version of the picture that was in the previous slide. Here we had conditions. Yes, we know if we add nitrogen or if you add phosphorus, what happens? And if you add phosphorus and nitrogen, what happens? And then when we add the fish. Now, after adding the fish, we did extraction of key components or key organs of the fish that would be of interest. One is the intestine. Did the fish consume the cyanobacteria or the green water? Of course, we expect it to consume, but what quantity? Then the primary target of the commonest toxin is the liver. We also extracted the liver, and then the other organ is the muscle that me and you will consume. So in this aspect, we use the Nile tilapia because in Lake George, for example, in the early 70s, there was research and has been proven that yes, tilapia can ingest and also digest the cyanobacteria or the blue-green algae. So that was the choice of using Nile tilapia. But also Nile tilapia is a candidate for aquaculture development. And of course, those who are familiar with our fisheries target, we are supposed to raise to produce 1 million metric tons of fish from aquaculture. And the three candidates of aquaculture is tilapia, catfish, and maybe miracup, or other candidates can come on board. But we had to choose at least a candidate that can serve both purposes, both in the capture fisheries and also in aquaculture. Now, what was interesting is, well, on the left, you can see, actually, if you pick a water sample what you're seeing in the green is green, but when you put it under the microscope, now you're able to differentiate what is in the green water. So in this case, there was the Oligospermum and Bena, the microcystis. There were diatoms, there was Planktolimpia, there was Merispedia. There are so many. They're quite diverse. Now, the time we introduced the fish and then kept on monitoring, we see that, yes, there was an actual decrease in biomass, the biomass of the green. Now, that is a good thing. It means there was consumption. So if we look at it in terms of, excuse me, in terms of control of the greening in capture fisheries, Nile tilapia would be a potential candidate to control. But in the process of controlling, it is also exposed to the cyanotoxins. Now, unfortunately, the green can immediately clog the what? Clog the gills of the fish. Excuse me. So, moving forward, when we look at the intestine of the fish, yes, there was, if we don't want to open the fish, we just look at the biomass decrease, the biomass decrease after adding the fish. But if we have to move forward and provide additional evidence, yes, we open up the fish, and in the intestine of the fish, there was green algae or green, I mean, not green algae, blue-green algae or the greening. Then we look at now the target organ. That is the liver. So in Napoleon Gulf, which is a little bit less green compared to Gaba and Roseberry Channel and also parts of Entebbe that are more green, we see that there was transfer of these toxins into the liver. Then on the muscle, of course, the concentration was very low. Out of the fish, the 15 fish we put in every bag during the experimentations, we find that yes, only 4. It's not so big, but it proves, it gives an implication that there is transfer and a potential magnification of the toxins in the fish. Now, that means we have additional threats, additional exposures, which we have to manage. But that is not all lost, because it's this the same lake where we are, the same lake where we do capture fisheries research, the same lake we are installing aquaculture facilities, particularly cages. And if you look at all the potential sites, aquaculture officers or people who are key experts in aquaculture should attest to this, most sites that are having aquaculture facilities are actually closed systems. Relatively closed systems. So that means, one, those systems can harbor the greening, and with less saturation, then we have a stable system of greening. Now, if all the inshore sites are lost, are green, we may actually not have any sites for installation of aquaculture facilities. Consequently, it will affect our target. That means we have to do offshore aquaculture development. Now, offshore aquaculture development comes at its cost also. This involves having either a field station within the lake, which is very expensive, or the aquaculture installation spends much more money in managing the facility than managing the fish. Then, of course, if we look at the, sorry, I had to take you back. In the control, there was nothing done. It means the tilapia is able to consume the blue-green algae or the cyanobacteria. Therefore, even if our cages are installed, and even if we are feeding them at one time these tilapias are phytoplanktivores. They will consume the phytoplankton, but of course in less numbers. And it could be also an opportunity, especially for fish farmers who do intermittent feeding, where they feed today, tomorrow, and then they run out of feeds. Of course, they're not very serious farmers, but we have them. So those are potential persons that are actually exposed to accumulation of this. Now, like I mentioned, and Laban mentioned, we at NaFIRRI, we are not just waiting, but we want to turn the greening into a wealth. Is it possible to turn this environmental nuisance into something that we can use? So we have done some experiments where we were using algae to actually do wastewater treatment. We have identified three candidate species that we can use. And then the fourth candidate species is actually very high in protein. And this was spirulina. And we made attempts to actually culture it. We get it, culture it, and use it to produce some bit of feed. Of course, we are not planning to replace the feed industry with algae, because the amount of algae that someone would require would be enormous. It would be very, very big. But this can be a supplement to the actual feed industry that is supporting excuse me, that is supporting aquaculture. Now, I am happy that Dr. Msinguzi began with where do we get information? So a journalist or somebody in the media has a way of reporting. For example, if you look at that, the journalist writes, algal-bloom crisis looms over Lake Victoria. That is in Uganda. Then if you go to Kenya, another journalist writes about the same, a lake of poison. And then a scientist comes and makes a lot of jargons, a review of the socio-ecological causes and consequences for bacterial blooms in Lake Victoria. These are talking about the same thing, but addressing different audiences. So this lake, the Lake Victoria that we are actually looking at today, it's a greening lake, yes, but it also has the potential. It's the one of the largest inland fisheries with production, inland fisheries production in the world. But sometimes what is reported in the media attracts so much responses attracts so much attention because of pitching. But this lake of poison cannot be the same lake producing Nile perch for export. Otherwise, we would have had a ban. We wouldn't be exporting any of our fish. So, and that is why we are having one of these webinars to actually come and try to pass out more information to our audiences to see that they get to know what is there. And of course, this is works that have been done over several months, several years, that also require critical analysis. So what will be required for us? One, we have had incidences of establishment of our farms, especially aquaculture farms. They are located in those closed bays, majority are in closed bays, if not in a channel, for example, Roseberry Channel, Buvuma Channel, and so on. Now, these areas are shallow, but we have to always monitor. The plan is to continue with the monitoring. Now, these photos of myself and my colleagues during the times we were monitoring several parameters. We monitor physical chemical parameters, the nutrients, and the biologicals. So that gives us like, how do we respond rapidly to certain things? Of course, we had fish kills in the lake I think in the early 2022, mid 2022, 2023. And people came saying it was poisoning and so on, but basically it was mixed. So how do we move forward? Well, we know our population is increasing. Therefore, we have to know that there's going to be continuous greening. The only thing we can do there is to improve our wastewater treatment. Otherwise, the lake will continue being green. And the different parts of the lake will respond differently, and that requires long-term monitoring. Now, in the same vein, when we understand these ecological functions of the lake, let us adopt sustainable land use management practices. Because if we do not manage it from source, it will continue up to when Jesus comes back. Thank you very much. Back to the moderator.
Yeah, thanks, Mark, for the presentation. I think this is an important topic that I believe members would like to give more time discussing. So feel free to stay around, maybe for an extra 10-20 minutes beyond 11 a.m. if you can. We shall keep the link open, and I hope, Mark, you'll also be able to remain here for those additional minutes to contribute to the discussion. So before I invite the participants to ask questions, make comments, and so on.
Yes,
I
they can raise their hands.
I
And,
like this analogy with this analogy about COVID. During the pandemic, we were hearing stories of new variants coming out, and I like this thing you talked about, that we have less variants that are toxic in the open water, which means that as we have more pollution of the inshores, we are actually laying a ground for more toxic variants, which may not even be fully removed from drinking water by treatment. So participants, you see the importance of pollution of these water bodies. So,
So we have hands that have been raised up, and we also have questions in the chat room. I think we should start with the raised hands. We have a hand from Abdul. Abdul, please make your submission.
Good morning to you all. This is Utamungu Zabron, no fisheries, the well of this local government. This is kind of an addition. Apart from using the institute measurements to collect data on the algae, how about if we can use imaginary data, maybe Sentinel-2 or Landsat-8, in order to monitor the algal blooms? Because basically the institute measurements come with some challenges. They are costly, and then basically you may not measure, you may not have the needed frequencies. As doctor says, we need to do the monitoring. But for example, when you look at Landsat 8, it can give you 16-meter resolution, sorry, 5-meter resolution, and a frequency of 16 days. Hello?
Yeah.
I'm saying that in addition to the institute measurements, we need adoption of using Landsat imagery, whereby we can monitor the algal blooms, because it has been used elsewhere in the eutrophic small lakes. Why can't we use it in Uganda? Because we don't have resources for in-situ measurements. I think the way to go is to go the Landsat or Sentinel way, whereby we can have some analysis and do some predictions, and also have data after 16 days and at a greater resolution of 5 meters. Thank you.
Okay, thank you very much. We shall allow 5 questions, and then we allow Mark and Laban to respond. So we now have Joyce Nyeko.
Thank you, NaFIRRI colleagues, for this wonderful presentation. Indeed, this is an area of concern which some of us have been looking at and wondering how to get about it. I am in touch with a scientist or a farmer from Israel who is willing to introduce algae-eating species. Is it possible for you to partner with him? We establish some cages in these densely polluted areas as part of experiment to see how fast these fish can clean those areas and if it can be something sustainable. Because if you are ready, I could invite this person to come and meet with you, and you take the discussion forward. I submit.
Thank you. Thank you very much.
Thank you. Brian Iga.
Thank you. Thanks, Dr. Laban and Mark. Hope I'm clear.
Yes, you are.
I think this discussion has come at the right time. Population is really skyrocketing, and being also one of the influencers. Now, there's this issue of climate change. I don't know in the final scenario how we are going to manage this, the current trends of climate change. I don't know what mitigation measures are in place, because we shall see ecosystem changes, imbalances. How are we countering this? Because they will be favoring the biodiversity, the organisms will now be shifting to refuges that are more plenty, or rather to do with the food webs and the like. Then the other thing is to this, like Victoria being a shared water resource. I think there is need for a holistic approach, bringing together the different stakeholders in terms of now looking at the policy, so that there is goodwill in management of this. Thank you.
Thank you very much. Ninsima Maxi.
Yes, thank you very much, Doctor. This is Mercy from Kachwekano. Actually, the previous speaker has just echoed on policy that I wanted to talk about, but to improve on it, my concern is what are the cost implications so far due to the greening of this lake? In other words, what is the economic value in terms of the fish capture and maybe on GDP. So what would be the policies or policy recommendations for this study for it to be able to attract more policy attention? Thank you.
All right. Thank you very much. Then Gerald Kwikiriza, and then we shall get responses. Brian, please make sure on the next round you ask your question. Thank you.
Yeah. Thank you, Mark, for this wonderful presentation, and thank you, Zawedi, for organizing this. Yes, my concern is about before the introduction of these fish, especially Nile perch and tilapia, procurements we are doing a great job on feeding on these phytoplanktons. And I understand after the introduction of these species, the proliferation of the greening continues. So Mark, do you have any relevant information in relation to procurements? Do you think they can be restocked? Can we enhance them rather than introducing in species from outside that could go ahead and even impact on the genetic diversity of the species which we already have? Thank you.
Thank you very much. Mark, kindly make your responses, and anyone who can support him, you're welcome to support him after he makes his submission. Thank you.
Thank you very much, colleagues. This is very, very interesting. One, I will start by appreciating the comments and additions. And for we at NaFIRRI, we are open to collaborations. And this one goes to Mr. Abdul and Mrs. Joyce Nyeko. We would be willing to partner to come up with collaborations and see that we tackle this problem. Like I mentioned, we are in this together, and we are all responsible for it. So when we find a collective solution, this is great. Now, specifically for using remote sensing, I was in touch with Dr. Sechanzi Arthur at Mountains of the Moon, and we were coming up with something, and most likely we would like to partner again with you. We can also come on board, and to also bring the regional aspect. We are working together with our colleagues in NaFIRRI and NaFIRRI, that is Kenya and Tanzania, to try to come up with a dashboard system for the whole lake. But of course, that is a work in progress. Now for climate change mitigations, we have to tackle it all together. It's not going to be a one-off of fisheries only. It's fisheries, natural resources, and so on. One interesting fact is Gerard's submission and Mrs. Joyce's submission to experiment some fishes if they can clean the lake and or enhancing the haplochromines that were actually doing the job before introduction of Nile perch. But let's not forget that after the introduction of Nile perch, we had industrialization. So we have sources of nutrients that is contributing to that. So like David said, we are going to come up, we need a holistic approach, and we are not sleeping. We have to take it on board. Now, Ninsima from Kachwekano, thank you very much. Laban was formerly a socioeconomist. I think he can help me here. Unfortunately, I myself have not participated yet in the economic implication study for this. But our colleagues in the socioeconomic department, there was just a perception study in Uganda, and then there was also a perception study in Kenya. Actually, the one in Kenya, I participated in identification of just the sites, but in the actual data collections, no. So how much economic value we can tag to it as of now, I may not be able to give you a concrete answer to definitely attract attention. Maybe Dr. Msinguzi can. Thank you.
Robert Gidoy asked that are the fishers, depending on the lake for livelihood, aware of the greening? And if
Yes,
they are, what are their perceptions?
The fishers are aware that they are aware. And of course, the perception towards the algae or the greening is not good. Like if you put the sentinel studies or sentiment studies, not very good. But they also say, I'll use vernacular in this case, the water that ends in the lake comes from the ridge. So we have to improve our wastewater management. I hope that one gives an indication.
Okay, thank you very much. And then there is another question from Mukasa Yusuf of NAL, and he's asking that has a cumulative dietary exposure risk assessment been conducted for the communities that are consuming the tilapia as a source of protein, especially considering the multiple exposures they get through the water, the fish, the shellfish, the vegetables, and the irrigated materials that use the water?
We haven't done cumulative studies, but what I can say about it is that in risk assessment, we take the bare minimum, and then we also have the TDI, the total daily intake that is allowed. So it is used as preventive to categorize the threats, the threat levels, acute, chronic, etc. But we use the TDI. Now, for example, a person who is 40 kilograms, I think, is allowed to consume, I don't know if I put it here, total daily intake. So we see that there are people who are consuming up to 128 microgram of the toxin in themselves. But now the maximum allowable is 0. If you are to do it daily, is 0.4 microgram per kilogram. So basically, we have not done it, but we can use existing information to predict your exposure, whether you are acute or you are doing chronic exposure, but also to which species. If you're eating fish whole, which we don't eat, we are less exposed because the toxins are, the algae is more in the intestines. But then if we are eating mukene, which is fully in water, and also it is everything eaten, it is potential. Of course, mukene doesn't eat algae, but it's zooplankton, which is in the chain. So it depends on also the fish that you're eating. Thank you.
All right, I'm going to now invite Hans to make submissions before I go back to the chat questions. Jesse Luja.
Thank you so much, Dr. Rokotum and Laban, for the wonderful presentation. Now, for me, like someone asked in the local way to put it, I would go local and ask what are the key takeaways for us who stay near these water bodies? what can we do? If personally, I was looking into the chat and Rose was saying for her, she has not contributed to the greening effect. But then for us, if we accept that, well, we are contributing, then how can we on an individual scale reduce, or what can we do to make sure that the greening doesn't continue? And then I would say that maybe you, the scientists, are becoming alarmists of a sort, because I know you do what we call hydroacoustic assessments, and then for us, the fishers, when we move into the middle of the lake, which is actually the biggest part of the lake, we do not see that green. So what do you talk about that? Could it be that you people are just making noise over something that is actually small? Or how does the big nature of the lake, because when you move towards some good kilometers, 40 kilometers into the lake, you see really, I would say, blue water, which doesn't have the green, and which we as the fishermen think that it is actually clean water. And then lastly, apart from sharing these in your offices, which have SC and ETC, how are you ensuring that this information actually comes down to us, the people on the ground?
Jesse, thank you very much for your submission. They are very interesting and highly controversial, which is good. One, we are all responsible. You said Rose did not contribute. If you've ever lived in Kampala, Jinja, Mukono, Entebbe, you have contributed to eutrophication of Lake Victoria. If you've ever gone to the beach and you've eaten fish, you have been exposed at least to cyanobacteria. So let us take this up. We are responsible and we're in this together. Now, how can we contribute to the reduction of the greening of the lake? Now, one, waste management. In this case, solid and liquid waste management. And we need to know that the causes of the greening is nitrogen and phosphorus. And once we manage that, we'll have managed. We shall have stopped, because someone asked me before the talk, do we have a condition after eutrophic? Because Lake Victoria is eutrophic, but now we are going to hypertrophic. Do we have something after hypertrophic? And I thought of pentatrophic. I don't know if it exists. But let us stop at hypertrophic and try to go back to eutrophic. Now, when we go to the middle of the lake, true, the lake is blue. True, the lake has algae, but also the lake has the greening. You may not be able to see it, but when you take it out, you get a sample of the water, you will get cyanobacteria, you will get diatoms. So in the open lake, there is more of mixing. In these closed systems, there is less mixing, but there's also continuous deposits from you and myself into the lake, enhancing the greening. Now, for scientists to sound alarming, well, it depends on the choice of what, but also the journalists who pick out work of the scientists, they make it sound like the lake is ending tomorrow. Lake of poison, yet is producing 500,000 tons of fish. If we look at just the component of, by the paper we published in Kenya, we sampled the whole of the Kenyan part, the whole of the Kenyan part of Lake Victoria. And it is the basis of the publication. But of course, as I mentioned, we have hot spots everywhere. Now, dissemination, unfortunately, my office has no SC, but dissemination, this is one thing we have started and we are doing it. And we appreciate the knowledge management culture should now continue more and more. But majority of us scientists, you will agree with me that we do not know how to write things simpler to be understood by the layman. So dissemination is key. We have been doing it in other ways, brochures, but people are not interested in reading your brochures. People are interested in reading short articles, short newspaper things, but it should be based on information. So we need, maybe this now, I also now use Jesse's submission to submit this to Secretariat, that we need that training as scientists to be able to communicate things done in 4 years in 1 hour. Thank you.
Thank you very much, Dr. Mark and Dr. Msinguzi. I thank you for that presentation. My concern is on one aspect, on the genetic system of fisheries. It is good your presentation has been so open, but it has left out the genetic system of the fisheries. It is unfortunate that the narrow system does not recognize that fish is not one, but it is fishes. Because fishes are many. You can have a program on Nile perch, you can have a program on tilapia, you can have a program on other fish species. But my concern is one. When you talk about the green, the genetic system of the natural water sources in the country, the water body of Uganda is a cannibalistic environment. That even when you talk about the green, there are those fish species which can feed on the green. Now, my inquiry is, if we embed or if we embrace the genetics of fisheries, like the crop people have embraced the plant genetics in Entebbe, and maybe the livestock genetics in the other side. In my own understanding as the support staff, we have not got a genetic system of fishes in Uganda. But what I believe is the greening of the lakes or the natural bodies or the water natural bodies can be a feed to certain fish species. I kindly submit. You can guide on that. Thank you very much.
Thank you, Brian. One, that is a key observation, and I attest to that Lake Victoria alone has more than 50 species of fish. Albert has 55 at least. Edward George system have 62 at least. Choga has at least 70. And to date, we have managed to describe morphologically, categorically clear that we have managed to describe at least 292 fish species. And these lack genomic characterization. That is a key observation. The majority that are genetically characterized, they are the ones our colleagues like the quick reasers are interested in, the tilapines for aquaculture improvements. So that is a key observation. And when you talk about the feeding mechanisms, that goes hand in hand with the trophic dynamics. In the lake, there is nothing for free. Bacteria is there, the green is there, zooplankton is there, feeds on the green, and so on. So it is a cascade. One thing we need to appreciate is the food web was simplified, but it's still supporting the system. Therefore, I will also add my voice to yours that Secretariat should not consider fish as fish, but fishes. And I don't know if we have somebody from the ministry on the group or on chat or on call, because there's a tendency of looking at small pelagics, large fishes, aquaculture, and then fish and fish products. But still, those do not sort out the challenges we're having in the sector. Thank you. Maybe if somebody
Okay, we are going to allow a few more questions before we close this, because we don't want to keep people for a very long time. I see we still have some hands up. I don't know, there is Geoffrey.
Thank you. And thank you, Dr. Mark and Laban, for this presentation and the wonderful information. My first question is, you set up this nice mesocosm experiment with the 15 fish, and it turns out that the fish actually eat these cyanobacteria. But of the 15, you find I think you mentioned the 4 that had the microcystin in the muscle, okay? And to me, the first interesting thing is all these 15 fish eat the cyanobacteria, but 4 of them have microcystin detected in the fish muscle. The first interesting thing is, could these 11 have something we can learn from? Because the bare minimum is they have all eaten the cyanobacteria, but microcystin is not detected in the other 11. So could that bring up something on the genetic makeup or enzymes in regard to enzymes that metabolize the microcystin? That's one area we could look at. The next thing is the occurrence of this greening is spatiotemporal, okay? I mean, you wake up one morning, you find the lake is green, you wake up the other morning, it's not there, okay? So it is actually an issue I'm looking at. If we went in for the option of having a fish as to help in degreening the lake, okay? These fish that we can bring to do that job, if we have the microcystin, the cyanobacteria this morning, next morning we don't have it, what will these fish eat? Won't they handle other useful algae in the lake?
Hello?
Maybe Joyce should come also.
Yeah,
All
my
right.
hand has been up. I know Barbara thinks that's an oldie hand, but it's a new hand.
Okay.
Yeah, thank you. I'll start from where the Ongera stopped. Yes, the Ongera, you may think that these things are special, but you need to, if you are very observant, the base, you just go to Nachiwogo, which is near your offices, and you will see you can literally scoop a soup of green. Yeah. If you go to Gaba, you can literally scoop a green. There are areas where this thing has not been splashed out much. And I still believe that there is need for us to clean the lake, because this has been cumulatively growing. The green was there, it will come and go, but it is cumulatively growing. And I think it's time action is taken to clean this lake. Now, there were 2 propositions. One is from me to bring fish from outside. Another one is to enhance the haplochromate. We can try both, because like you are seeing on the screen, your screen currently, you can do a same experiment. You can set these fish in cages. They don't have to be put in the open water. They can be put in cages in those specific areas, and these cages are movable, so that wherever this green is, because our intention is to reduce first what has accumulated, and then we go and answer, what can we do? I wanted also to answer my brother, the person who talked about fishermen. Yes, you may go deep in the open water, where the water you can even drink, despite having that dissolved toxins in it. How about you when you come back to your landing sites? Where do you get water for bathing, for drinking and cooking? Isn't it the same heavily contaminated water? That also needs to be taken into consideration by fishermen, because they too are contributing to the greening of the lake, and they need to participate in that.
Okay.
Economically, this fish is very, at a beach level alone. Last year, at beach level, we generated 2.96 trillion shillings going to the fishermen. 2.9 trillion shillings. You can imagine how much we lose if we lose the fishery. I stop there.
Thank you very much. We have 3 new hands and we have 8 minutes to go. Ivan, Chikomeko, and Shafiq. But Shafiq's hand has been up the longest, so maybe Shafiq submits first.
Okay, thank you very much for the insightful presentation. I'm Shafiq Kajim, working with FIAN Uganda. In reference to the presentation that highlighted waste loading, are there any specific industries or culprits that have been identified that we could maybe target in our advocacy efforts for improvement? From the business perspective and human rights perspective, corporate entities have a responsibility in resource protection. And lastly, additionally, what role can civil society organizations play to support this process? Thank you very much.
Let's take all the 3 hands. Ivan, or they are for now. Ivan.
Yeah, thank you, Dr. Zaweda, for moderating this meeting. And to you, Mark and Raban. Mark, I wanted to inquire to what extent NaFIRRI is working with the other stakeholders, especially Minister of Water and Environment. Because in your presentation, you seem to have focused mainly on cage aquaculture, which could be one of the contributors to the greening that we are facing. But I'm wondering whether we've been able as NaFIRRI to quantify or to find out what other contributors, especially industries, how much are they contributing this greening we are facing? Because as you clearly put in your video, the areas which we are seeing having more of green are actually not having cages. Cages are far away from those areas. And to my thinking, we may be having more of the nutrients that are responsible for greening coming from these cages. I mean, from these industries. Besides, NaFIRRI has the mandate for citing areas which are suitable for cage aquaculture development. And I would think over time, NaFIRRI goes back to find out what is happening there and give recommendations on the appropriate carrying capacity for those bays in order to mitigate the nutrients that are being exposed to this environment. Is NaFIRRI doing that so that we then as NaFIRRI not be seen as also responsible for promoting this greening on the lake? Thank you.
Thank you. Adisan Chikomeko.
Thank you, Barbara. My submission is related with Ivan's, but a bit different. Still regarding the intersectoral collaborations between NaFIRRI and other agencies. Now I understand that the Lake Victoria is managed under the fisheries management plans, and there are also management objectives that are a bit related to the use environmental impacts from other activities. So my question is, how has NaFIRRI and maybe other entities, state actors and non-state, been able to evaluate the changes in trends of these of pollution, and which policies or which other actions have been taken in the policy direction? That is my submission.
All right, thank you. And we have a hand from Gerald Kiriza.
Yes. Thank you so much. Actually, I want to make a contribution to the question which was asked by Brian Yeager. He was inquiring whether there are some genetic studies which have been done on our lakes. I can say we have more than 20 papers which are done, especially looking at the genetic diversity of the Oreochromis species in all the water bodies, I can say. And of course, we have also gone ahead to characterize fish from the farms. But what is missing, the gap which I also see that is missing, is with haplochromines. The studies with the haplochromines, as they for sure play a big role in reducing the green, is limited. So if we can team up and do these studies, maybe get an haplochromine species which can be able to reduce this green algae, it would be the best addition to our sector. Then, lastly, this issue of the big shots, we look at pollution from industries. Maybe the state is also playing a big role. I don't know. Mark can advise on how to go about that. We look at aquaculture. Most of these big investments are coming from big shots, but when we make these recommendations, we only focus on science and the low person. What can be done for sure? Thank you.
Okay, great. Thank you very much, colleagues. And this is summing it up and it's coming up very well. Geoffrey De Ongera, I think we are going to get further in touch because one, we are all going back to the genetics. What happened to the other 11 fish? Is it possible there was no direct transfer? Did it just stop in the liver because it was there? So that causes for more studies. But as mentioned, the spatial temporal dynamics, we have done this. What changes is just the species from inshore to the open lake. Is just species and biovolume or concentration, but it is still green. Joyce's submission was additions and comments, which is highly welcome, and we appreciate that, even Gerard. Now, I will start with this one. Well, NaFIRRI has done pollution studies under several projects. I mentioned the interventions we've had in terms of pollution or water environment studies or projects. There was Lake Victoria Environmental Project, then LAVEMP, the 2 phases. I don't know if LAVEMP 3 is coming, but we have the first one characterized the pollution. The other one came to manage the sources of pollution. I don't know if we are going to get LAVEMP 3 that is now going to do another approach. I don't know if it is coming. And in the implementation of LAVEMP, for example, we were doing it with the Ministry of Water, and we do collaborative research with them. Actually, up to now, we have monitoring stations in the lake. Now, Dr. Abaho, well, I don't know how much the cages are contributing. I saw my colleague, Mr. Chaya here, but the cage facility that NaFIRRI used to monitor was the sunfish